Why do we need quantum gravity? Hello, in this short video I will explain why do we need to quantize gravity, namely why the gravitational field has to be quantized and why gravitons must exist uh, in a full theory that includes both electroweak strong uh, and gravitational fields. Let us use the following idea, the idea of Heisenberg, which is called Heisenberg's microscope. Suppose that I want to know the position and the momentum of a single electron. And I'm using a microscope to tell where is the electron, what is the momentum of the electron. So that's a microscope. Microscope is using electromagnetic waves, light, and upon quantization, we call them photons, single particles which are called photons. The issue is that each photon by itself has a certain uncertainty in its momentum delta p and in its position delta x. The reason is the following. A single photon has a wavelength lambda, and therefore it has an uncertainty in the position which is of order lambda. We cannot use a photon of a certain wavelength lambda to tell the position of the electron to an accuracy better than lambda. At the same time, the momentum of a photon, and that was already known in 1925, is h over lambda, and therefore this is the uncertainty in the momentum of the photon. So Heisenberg realized that for a single photon, delta x, delta p is h, or at least h, Planck's constant. And therefore, using a photon which admits such an uncertainty in delta x and delta p, we cannot deduce the position and the momentum of the electron um, to an accuracy better than delta x times delta p greater than um, h. So less than h. And that's the famous Heisenberg's uncertainty principle that he discovered using this Gedanken experiment, which is called Heisenberg's microscope. Let me use the original idea of Heisenberg to argue that we have to quantize the gravitational wave interaction, namely that the gravitational field must be composed of gravitons. So let's see what's the idea, which is rather simple. Again, suppose that we have an electron. But now let's try to probe its position and momentum not using an ordinary microscope made of light or photons. Now let us use gravitational waves. So gravitational waves uh, exist. They were observed already in LIGO. So that's an empirical fact. Now, the question is whether these gravitational waves are classical waves or they are made of gravitons. And let me argue that they must be made of gravitons. Why? If these gravitational waves are classical, then they do not respect the uncertainty principle, Heisenberg uncertainty principle, that delta x, delta p has to be at least h. So The original argument of Heisenberg relied on the quantization of the electromagnetic wave, namely that electromagnetic waves are made of photons. And that implies the uncertainty principle. If gravitational waves are not made um, of gravitons, we can use in principle gravitational waves to find the position and the momentum by scattering off gravitational waves of the electron. We will be able to deduce the position and the momentum of the electron to an accuracy better than delta x, delta p of the order of h. So the idea is that in order not to violate Heisenberg uncertainty principle, the gravitational waves have to be quantized. Gravitational waves must be made of gravitons that respect the uncertainty principle. Again, if the gravitational field is classical, we will be able to use it in order to violate Heisenberg uncertainty uh, principle. So that cannot be. Gravitons must exist. Gravitons must exist. And therefore, we have to learn how to quantize gravity. Gravity cannot be a classical field.